I'd like to present to you our efforts to improve KiCad, to bring it in par with some mid-range proprietary tools, and our plans and our achievements so far. Maybe we'll try to design something if it will work, because it's a development thing. I'm sorry if this is a bit improvised. Eva put a lot of effort to prepare herself. On the other hand, I was struggling with a bug in this for half of today, so I didn't have much time to prepare. So,
is there music somewhere?
Oh.
Yeah,
it's part of the presentation.
So the presentation will be about our contribution, our future plans, and why we contribute to KiCad at all.
For the sake of the recording, shouldn't you
in the microphone?
Sorry.
If it bothers you, it's fine. I mean.
No, it's just okay.
Is it on?
Yeah,
It looks like. So there will be a presentation first on our why we support KiCad, what we'd like to achieve, and what we've done so far, and what are our future plans, and then a short demo, and maybe we'll design some small PCB. We'll see. So the outline is, first I'll talk a bit why we got involved into KiCad, what we've contributed so far, what we plan to do next, and then a little summary in the demo. So why? Well, I think Javier explained it after Eva's presentation, but just to repeat, we simply found that there is no good quality free open source PCB design tool that would be capable of handling our designs without much effort. The other reason was that the proprietary tools that we use have incompatible formats. That was also mentioned, and these formats, they seriously damage the possibility of collaboration between us and different companies or institutes. For instance, at GSI they use ORCAD. So in order to simply fix a bug in a GSI board, for us we would need a ORCAD license, and the same way, if they wanted to fix a bug in our design, they would have to buy an Altium license. Besides, as Javier mentioned already, the really advanced proprietary PCB design tools are usually very tough to learn. If anybody of you has ever used Cadence, you'll know. So our involvement was that it was roughly 2 years ago, after the Open Hardware Workshop we held in Grenoble. We gathered the requirements, and we identified that there are two competitors, KiCad and GEDA. We discussed with the developers and users of both, and the outcome was that we picked KiCad as our tool, thanks to the fact that it's truly multi-platform, so it works, or it aims to work reliably on Windows, Linux, and Mac OS X. This was not really true for GDA. We aimed for a tool that is easy to use, that provides an integrated design environment experience. That means if you want to design a PCB, you just click it in the simplest form. You don't have to use any scripts. You don't have to program anything, to edit any files by hand, etc. Ease of use was the main concern. And the third reason was C++. GDA is written in GTK, with glib, with all the sorts of, well, technical choices that we didn't consider optimal, least to say. So we prepared a very big list of work packages. recently we created an official fundraising website through Cern Knowledge Transfer Group, and it even gathered its first donation. And we hired a very talented C++ programmer who's sitting right there. So what we are aiming at, we'd like KiCad to be in par with mid-range proprietary tools like Altium or OrCAD. We don't mean to put Cadence or Mentor graphics out of the market or even compete with them. It's just the range of features that we would like to have is the one we need for effective design and support of our PCBs. So up to, let's say, 10, 12 layers, up to 5,000, 6,000 pins, 2,000 components per board. So it's not the highest end, but still pretty high. We would like to be able to design most of our PCBs solely in KiCad without relying on any external proprietary tools. We would like to have a truly multi-platform suite. And if possible, this is still discussed at Cern, we would like to support the open hardware community with some quality PCB libraries, and this might become possible at some point through conversion of our proprietary format libraries and putting them in the open. But this requires an agreement with people who are in charge of these libraries. So we started with a pretty ambitious plan. Geometry framework, new graphics engine with OpenGL, rewriting the stuff to follow model view controller architecture, push and shove router, more intelligent drag and drop tool, templatized pages, plugins, modules, improved GUI, improved design rule checker, etc. The list is even longer. You can find the work packages on that website below. If someone of you is interested in contributing, you're very welcome. We have enough work. We have quite a lot of work to do. So our the first thing we developed was the new graphics engine for KiCad. So the current stable version of KiCad relies fully on software rendering, which well, it works for small boards, but for a bit larger designs, it's so slow that it's simply unusable. We needed to have proper hardware acceleration. It also looks a bit outdated. So it uses rubber banding, soaring to redraw moved items on the screen, sometimes causes rubbish. So we addressed these issues with our OpenGL engine, and for those of you who don't have an OpenGL hardware, you can use a Cairo backend that is slightly slower but still capable of handling small boards. So this is just a little static photo of a complex 12-layer board rendered by this thing. The next thing that we developed is a small two-dimensional geometry library that kind of unifies the geometry algorithms used in a typical PCB design program, such as polygon clipping, collision detection, shape indexing, fast searching of matching shapes, etc. This is already used by one of the tools that I'm gonna show you later. We also developed a tool abstraction layer. So in the current KiCad up to now, the tools were written in a very, let's say, entangled way. So there were multiple entry points. They were just running a huge state machine, handling events from the GUI asynchronously. The tools couldn't be easily modularized and put into not very interdependent pieces of code. So this is the part where we wanted to improve, and we proposed something that we call internally a tool framework. It's also based on state machines or coroutines. and it abstracts each tool into a separate class that can be connected independently of everything else to KiCad, so that independent people can work on independent tools and not conflict with each other. We have developed the first two tools to demonstrate this framework. It's a drag and drop tool and a push and shove router. So as for the drag and drop tool, it's basically KiCad used to follow the old style fashion of first select an action and then do something. But this is not really the typical use case for modern GUI programs. The usual workflow is that you select an item and then you are given a set of actions that you can do with such an item. If you take any typical application like Office, like GIMP, like Inkscape, like Photoshop or anything else, they usually follow this paradigm. We wanted KiCad to be usable for entry-level users who have no prior experience, to simplify the learning curve. That's why we wanted to change this approach. So this tool is just a generic drag and drop tool, like in any other graphical design program, but adapted to a PCB design environment. And probably the biggest contribution so far is a push and shove router. What's a push and shove router? So imagine that you have a huge pile of traces obstructing some space in the PCB that you want to route your next track to. So with without push and shove, if you wanted to free the space in the PCB to put a component to route another one, you'd have to move everything by hand. Push and shove does it for you. It makes the traces behave as if they were flexible, and then if they collide with the trace that is currently being routed, they are automatically moved away. So there is an initial version already available. It's a bit unstable, but it more or less works, and more features are coming soon. So this shows the idea. Oh shit, no, sorry. So what are our plans for the nearest future? I'd like to finish the push and shove and drag and drop tools. We are also currently working on a new rat's nest engine. The rat's nest is the air wires, lines connected to pins that are not yet routed. We'll be working on porting the remaining PCB editor tools to the new tool framework, on also on converting the rest of the KiCad code base to model view controller architecture, increasing number of layers in the PCB, modularizing the code by means of splitting the monolith of KiCad PCB and schematic applications into DLLs, into loadable plugins. We will put some special effort on ensuring high quality, well, let's say equal quality and equal user experience on all the platforms, because for instance, the macOS version is a bit lagging behind after Windows and Linux ones. And I'd like to put more effort on planning, management of KiCad, and also documentation. So we'd say that KiCad is becoming quite efficient for moderately complicated design. We invite more developers to come. There is plenty of work to do, and especially with this module, when these modularization work packages are done, we will be able to just provide a set of things to do, so that people can take them, implement them without any conflicts with each other, with any other developers. That's why we plan to we are planning a hackathon, maybe not in the first quarter of 2014, but a bit later, around summer. And that's it. There will be more KiCad cool stuff coming from Cern soon. You can always check our repository here. Thank you.
Maybe I would add one thing that you don't need to check that repository because recently it was merged into testing branch. So I invite you to try it out, and I look for testers because it's still development version. So hopefully there are no more bug reports, but still you are welcome to try it.
It was written time for a demo.
Okay. Well, let's check if it has compiled already.
Is it still at 4%? Oh,
yeah, it finished at 4%. But
4% is just enough.
seems to be enough.
Yeah, there was some recording.
It's less than beer.
So, for those of you who, how many of you have used KiCad before? Okay.
I tried.
I'm not raising my hand. It's fine. It's a shame to admit, but I developed for KiCad. But I feel too lazy to design my PCBs in it.
At least for now.
But this is gonna change soon. But nonetheless, for simple projects like, let's say if you want to design something with small AVR microcontroller, all the things are already available in the stock libraries. So, for instance, we can take an Atmel CPU. We can add a bunch of decoupling capacitors to it. Sorry. It's hard to look simultaneously at the screen and to edit something. So let's clone them. So once you know the keyboard shortcuts, it's actually quite easy to use.
Can you use them customly, the keyboard shortcuts?
Yeah, you can define hotkeys for most of the actions, like here.
If there is a shortcut, is the program telling you or crashing?
Mm.
If you do a short circuit.
Well, on the schematic, if you make a short circuit, you make it deliberately. If you short the wires,
that's what
right?
I want.
So if you make them shorted, well, you'll have them shorted.
Perfect for
On the
this
PCB, there are two things that prevent you from making a short circuit. The first one is the design rule checker. So it's simply, once you've finished designing your PCB, you run it and it shows you all the errors, like this trace is too thick, the other trace is too close to the edge of the board. These two traces are short-circuited. And our newest and coolest thing, the push and shove router, it automatically keeps the traces at correct distances. So let's say designing a PCB from scratch will probably take too much time. So maybe I'll launch something.
Here's one. Pay attention.
Something already done. I forgot that I have hybrid graphics in that laptop. So let's make it use the full potential of the OpenGL backend. So this is a simple PCB, well, relatively simple. designed by some open hardware folks. It's a software-defined radio board. So this is the software backend. You can switch to OpenGL. This is the hardware. This is the hardware accelerated one. It brings also some goodies such as transparency.
Very nice.
Yeah. Well, it's hard to demonstrate a graphics engine for a CAD for a two-dimensional CAD application, other than to compare it against the software backend. Well, looks, this is choppy. The frame rate is poor, and here it's perfectly smooth. That's the only difference that is visible to the end user. And Orson developed a very nice select tool.
Yeah, which can just click, you are doing good.
Basically, when you, for instance, when you select multiple objects, it asks you for clarification.
Maybe it doesn't look like something very particular, but it's different from a
And
previous
then
workflow.
it moves stuff.
And the push and show, or at least
No,
push?
the move is without push and shove yet, but we are working on adding push and shove router to move operations. But basically, it works as in every other typical GUI application. So drag and drop. We are trying to make it as intuitive as possible.
So how does it work with overlapping traces and connections? So these are not connected to the resistors now?
In fact, they are if you put them back.
Okay, excellent.
Oops.
Aha.
Okay. I knew this was going to happen.
No blue screen.
This is a fresh.
filling bug reports.
Well, actually, this is a fresh build from a development branch.
Is the autosave?
Well, it's not even published, so
Okay.
Which version is there now? Like the official version?
there in the testing branch you can find the push and shove router, but for example no RATSNet because it's still under development. And but yeah, there are still goodies, and RATSNet is supposed to come there. I hope
It's like
next
the
week.
resolution is a bit too low to show all the icons.
Well, that's the fault of the projector then, no?
Hmm?
Is that the fault of the projector?
Well, you can say it this way. So this is the push and shove thing.
Oh.
So neat.
Well, this version is a bit buggy, but I'm working on an improved one. So it does not always solve all the possible cases.
But anyway. Oh, nice.
Looks good.
It's also a debug build, so it's horribly slow. Because it outputs a lot of useless messages.
Is it following the design rules?
Yeah. Fortunately, in KiCad the design rules are pretty simple, so you can just define clearances per net. It doesn't have to take care of different board regions or different layers. That made my life a bit simpler when writing this.
Does it take also into account difficult layout rules like for high frequency stuff? Or?
Not yet. Well, there is no concept of high frequency wall signal integrity rules in KiCad. This is something that somebody certainly needs to work on, but just not right now.
Can you tell it's a route with curved tracks instead of
Not
angle?
yet. Not in this router.
Okay, not that it really matters
So-
for any of our circuits yet.
Is it intended to have some config file when you can define constraints on how you want things to be like écarté, shift.
You mean the stack up of the PCB? Or
The design rules.
the design rules?
Yeah.
So
the
currently,
space between tracks and so on.
currently we have a simple dialog.
yeah.
So you can define net classes. For each net class, you define the clearance, the width, the via sizes, and that's it. That's a very well, let's say limited DRC setup, but for typical microcontroller designs, if you're not into gigabit realm, it's okay. Certainly, at some point we will work on improving the DRC. There is a work package on that. I had a plan for a fully scriptable DRC engine in mind, but this needs to be discussed with the main KiCad developers, and we need to get their approval.
So how would you, if you have a net and you want to assign it to a particular net class, how does that work?
Well, you go to the
Okay.
to the sorry, you go to the rules, then you can create another class. Then you select it here, and for instance, you make the stuff like this.
Okay, nice.
And then you can define a separate clearance. I'm not sure if the router will follow it. It might be buggy.
But the design rule checker will check it.
Yep.
Right.
So it's not perfect yet, but we are working on making it perfect. Okay, so that's it.
So you mentioned the main developer. Is there? Yeah. So Cern didn't just took it over, or there are still
No.
two,
There are three main
Everything involved.
developers of KiCad, and well, they basically run this whole business.
Okay.
We are currently a subcontractor.
Contributors.
Yeah.
But they are like full time? No. They are
No.
doing-
No,
Okay.
they are doing it voluntarily.
The only person full time on KiCad is also.
Yeah. Exactly. But they still keep the hand on it since they started it.
Yes.
Yeah.
But you also get, so you have a good relationship in the working, or how is it?
Of course, I mean, can you imagine merging that into something? And this is a lot of code, I can tell you. If they, there has to be a lot of confidence to accept that merge.
Yeah.
So we know these main developers since 3 years already, and we have been discussing with them a lot.
Okay.
We have met Jean-Pierre Charat, who is the father of KiCad, several times. He's in Grenoble,
Okay.
so he's not far away. And we have discussed with the other two developers very often. So yes, of course, we don't embark on something like this without being in good relationship with the main developers.
Yeah, okay, that's good.
Yeah. So this is how the code looks like. There's like 150 kilobytes just for the push and shove router. It will probably grow a bit in the future.
What's your editor?
It's Sublime Text for C++.
Sublime Text.
Yeah. For VHDL and Verilog I use Emacs because the mode for VHDL is an out-of-the-box product. So you install Emacs, you add the VHDL mode, and it just works. On the contrary, I've been struggling to set up CDT for Emacs to have goodies such as class browsing or auto-completion for C++ and Emacs, and I failed. It's probably very, very powerful. I just don't have enough time to make it work, so that's why I use Sublime. I didn't want to go into Eclipse and Visual Studio or other really big environments. Okay, thanks.
Let's eat pizza.